Good morning to one and all present here. I am Brahaand here to present my report on the problem 10, which is magnetic gear. Problem statement. Take several identical fidget spinners and attach neodymium magnets to the ends. If you place them side by side on a plane and rotate one of them, the remaining ones start to rotate only due to magnetic field. Investigate and explain the phenomenon. Now, as you can see here, when one of the fidget spinner is rotated, the other one automatically starts to rotate only due to magnetic field. Now, there are many factors which affect this phenomenon. The first one being the distance between the two magnets. Now, as we know, when we decrease the distance between two magnets, the attractive force increases, and also it increases when we increase the strength of the magnets. Now, there are also loss of energy in the system due to friction in the ball bearing, air resistance, etc. Now, for this project, I've used cylindrical neodymium magnets because they're convenient to fit them to the fidget spinners. Force between two cylindrical bar magnets. Now, force is a function of the distance between the two cylindrical magnets is given by this formula: mu naught pi by 4 into m square r power 4 of 1 by x square plus 1 by x plus 2l whole square minus 2 by x plus l whole square, where x is the perpendicular distance between the faces of the cylindrical magnets, l is the length of the cylindrical magnet, r is the radius of the cylindrical magnet, m is the magnetization value. What is magnetization? Magnetization is the density of permanent or induced dipole moment in a magnetic material. In this case, a cylindrical magnet. And mu naught, as we know, is a permeability of free space. Now, if you want to calculate the effective magnetic dipole moment in the cylindrical magnet, let's assign it a value small m. It will be equal to the magnetization into the total volume of the cylindrical magnet, which will be equal to pi r square. Now, if at all we make the approximation that the length of the cylindrical magnet is lot lesser than the distance between the perpendicular faces of the two magnets, then we can reduce the our former equation to a smaller one, which is 3 by 2 into nu naught by pi m1 m2 1 by r power 4 x power 4, sorry. Now, but in this case, for in the investigation, I have not used this approximation. I have used a former longer equation. Now, experiment. So for this experimental setup, as I had mentioned before, I've taken two fidget spinners uh, to distinguish them in two different colors, red and green. And I've taken neodymium magnets of dimensions, the radius which is zero point 0.8 centimeters and thickness of 0.3 centimeters. Now they were all, so there were 16 of them, and these two fidget spinners were eight sided. So I stuck one of them to each of the sides of the fidget spinners in such a way that in one of the fidget spinners, that in the red one, the north poles were facing outwards, and in the green one, the south poles were facing outwards. And the distance between these magnets were varied by taking four different cases. Now, I took four different cases where case 1 was the 30 mm, case 2 being 20 mm, case 3 10 mm, and case 4 5 mm. Then I made this observation table. Now, for 30 mm, the observation was that the non mechanically driven spinner was at rest. What does that mean? Now, the mechanically driven fidget spinner, which was rotated by hand, was spun, but the non mechanically rotated fidget spinners did not move at all, though there was a force of magnetism. Now, in the 20 mm case, the non mechanically driven fidget spinner only oscillates. By oscillates, I mean to move in anti-clockwise and clockwise direction by only about certain angle without completing a single revolution. In 10 mm cases, the number of revolutions was not the same in the mechanically and non-mechanically driven fidget spinners, which means there was a partial interaction. Now, moving on to the 5 mm and the last case, the number of revolutions was the same, but lagging was negligible. When the experiment was conducted, lagging occurred only about once in about 10 times. And all these force of attraction between the magnets has been calculated from our former longer equation. Now, moving on, here I have plotted the force versus the x graph, where x, as I stated before, is the distance between the faces of the two cylindrical magnets. Now, y-axis represents the force in Newton, and x-axis represents the perpendicular distance between the faces of the two magnets, and it's given in meters. Both of them are in SI units. So, if we observe this particular graph, the second quadrant is non-real because the distance is negative. The first quadrant, as the distance increases, the attractive force decreases. It's a decreasing function. So we can clearly conclude from this fact that as we increase the distance between the two magnets, it decreases. But we can't say it directly. It's inversely proportional to the distance between the magnets because it's not an inversely proportional graph. It's as it's clear from our plot. Now for some conclusions. Now, as I had mentioned before, this is a decreasing graph, and so as we increase the distance between the two magnets, the attractive force is definitely going to decrease. But as we saw from our observation table, even above 5 mm, the attractive force does exist, and we have calculated that from our equation. But lagging is observed. This could be due to several reasons because of the presence of the friction in the ball bearings as well as the air resistance. And then the friction caused by ball bearing could have been reduced using lubricants for better results. And these observations, this investigation could also be improved in several ways, such as by changing the weights of the two fidget spinners, which could have influenced the number of revolutions made. The number of magnets could have been varied by varying the number of five sides of the fidget spinners, and the strength of the magnet could also be varied, which wouldn't have brought any change in the graph, but it could have brought a change in the our observation table. Thank you.